Welcome. My name is Hans Koch and I will present to you this talk about the Phytonic DCC environment. That's the main question that I ask myself: how should a middleware be? And my answers to this are easy to use. They should be easy to use for their users. And it's also important for many calibration labs that they don't want to change the existing workflow, so that should support it. Then keep the complexity invisible. Make it very simple for the user. And all that is more complex should be behind the scene. Allowing simple and reliable verification is important. Know whether the software is okay, is it working fine or not. And it should be open for future developments. I selected a practical case study. Many calibration labs, if not most, start with an Excel file as a template, and then they convert it to a PDF, and that's then the conventional certificate. And my small software that I developed, X2CC, you can start on the desktop with this symbol, and this will open a window, a small window, very few things to act on. You start to browse, you browse for the folder where the Excel files are in. It is all quite conventional. You select the folder, and then this tool comes up with a list of the Excel files that are in this folder. All other files that are in the folder are not shown. You select an example, or if you want to do a batch job, you select several of them, and then you click, and then the result will be an XML, a DCC out of this template. And not only that, we will have also a PDF, and this PDF is generated from the contents of the XML. So this because the purpose is that this allows then a convenient verification whether the XML is okay or not. Let's look for the first step from the Excel template to the XML. Actually, I start with a sample DCC, some DCC or sample that is nearly complete, and from information that I get from the Excel file, I develop then the new DCC. The middleware modifies only those XML elements which should be renewed. For instance, in the old file, you have the receipt date, 23rd of April, and in the new file, it should be an updated date, 26th of April 2020. So how is this done here? I have a Python code that makes just that. At first, I highlighted only those lines of code that have to do with the XMLs. I import a module from Python called etree and a small helper function indent. And with this etree, I can pass the DCC template. I get the root and I define the namespaces. And later, after we have done the job, then this new DCC XML is written. In between, there are the other highlights that are related to the XML, to the Excel file. I use OpenPyXL, and with this I can load the workbook, that means the Excel template. And if this template has several worksheets, then I select the worksheet that I want to look for. And that's all. And now we do the job. We look for the element, the relevant element of the receipt date in this template. Then we look for the value that is in the Excel template, make a string out of that, and override then the old receipt date by the new receipt date. And if I have other things to change, I do the same job. I look for the related element and the template, then I look for the contents of the workbook of the Excel template, and I override again the old text with a new text. This you can do with all the elements that have to be changed, and I think it's quite a simple job. It can be more complicated if the Excel has a lot of links and so on, but the basic software construction is like this. So let's have a closer look to the second step. Here I use Report Lab and not XSLT. And this I do because this allows fully automatic workflows, for instance batch jobs and so on. Partial Python code of this is where I use Report Lab and I make a story, and the story is made out of paragraphs, and then this is rendered to a PDF. So this is the highlighted part, is the part of the Report Lab, and in between we see how we enter data into this file. We get the receipt date again from our XML file, and we make a string of that text, and here we have some lines that change from the XML style date into a user-friendly format. How it is, for instance, common in German. So I started with the middleware, how it should be with some aspects, and here we have fulfilled the first two. Easy to use. I showed you, we just browse and click and keep the complexible invisible. All these programs you don't see, you only see this graphical user interface. One can construct this graphical user interface also by a Python file, PySimple GUI. This is a partial Python code of this. You see here, browse to Excel folder, browse to Excel folder, convert to calibration certificates. All these elements are then constructed with these few lines. Excel browser is the title. And then one is waiting for events. For instance, if you click this exit, then the whole job will stop, or you look for the folder, and so on and so on and so on. So this is also quite simple and I think also self-explaining. So little or no change for the existing workflow we have done, allowing simple and reliable verification. The PDF is generated from the DCC. This is one important step for this. And why do I use Python? Because the whole workflow with one language is my aim. Python is easy to learn. It has a good readability. See, for instance, the W schools. Many excellent tools for all purposes are available with Python, for instance, also Sign, XML, Flask, and so on and so on. So this is open for future developments, and you can construct a whole Python environment for your DCC. That's it, what I wanted to tell you. Thank you very much.